Welcome to this new video. We are going to create a simple state machine. This is just a random video that I thought of creating a state machine to control a screen in embedded using ESP. So we are going to be using an I2C OLED screen, the small ones, and the whole goal of this video is to help implement a very basic state machine to show how screen control is done. Things like menus, default screen or default displays, and controlling it using a button to cycle through the different menus that we have. So I have created a folder. I'm just gonna open it. I've created a folder and called it OLED screen FSM, as you can see here. But then I'm gonna open this in terminal and then create a platform IO project here. So the command is pio project init dash dashboard. I'm going to be using ESP32, do it, devkit v1. Press enter. That should initialize the directory structures, and if we list this as a if we list it, you're gonna see this folder. So include lib, src test, and git ignore, and then our configuration file, platform IO ini. So I'm going to go to src and create a file called main.cpp. Okay, this is cmd. So let me just open this with bash, git bash. So I'm gonna say this is this is ls cd into src, then touch main.cpp. All right, cool. Then we go into includes. We go into includes, cd into includes, but include, not includes, cd into include, then create a file called defs or diff. Let me call it defines.h. Okay, that's fine. So we can open this folder with code or VS Code. So I'm gonna say go to the parent directory and then code dot. That should open VS Code. Minimize that and good. So if you look here, we have the main.cpp file, and then now the most important thing here is platform IO.ini file. This is a configuration file for platform IO. So basically it's the one that tells us things like the platform we are using, the board we are using, and the framework. You can see I'm using the Arduino framework here. You can use things like ESP IDF, etc, STM, etc. These platform IO supports thousands of boards, possible boards. All right, so one thing that I like to add anytime I create a new project here is the upload speed and the monitor speed. So I'll say monitor speed is equal to 115, 200, and that's I'll add the upload speed later. Upload speed. So what this does is just it helps when you're uploading the code to the ESP, just fastens the process. Later, it fastens the process. All right, I'll comment it out for later. So my main file of interest is the main.cpp file. So I'm just gonna open it, and then Let me just change the view to this. Let me put it in Zen mode. All right, cool. So the first thing we do is include Arduino framework. So this is we expose the APIs for Arduino on ESP, which will help us to write faster code for such a basic example. So one more thing that I like to do is document what I'm doing or what this file will do. So brief describes the file in like one sentence or two. So I'm gonna say this file implements a basic state machine for an I2C OLED screen. Right, so I'm gonna move fast, but I know you will understand. Next is define two functions. Like in Arduino, you have void setup and you have void loop. Setup and loop. The next thing I want to do is include my defines. I call it defines.h. So defines define my constants basically. They define the constants that I have. So if I open that file, include defines. Let's see. Not copilot. Okay, so I'm gonna open this in a new editor. Let's see, split editor. Right, cool. So defines is on that side. Can close it here. Close. Okay. So here I'm gonna say if not defined defines h defines h, prevent multiple inclusion. Then I'm gonna say end if. All right, so you can also use pragma ones if you want. This is CPP pragma ones. Yeah, but I prefer this older method because of C language. Anyway, so the first thing I'm going to define is my baud rate. Define baud rate as 115 200. All right, the next thing I'm going to define is the screen width and height. So I'm going to say screen rows screen width, I'll show you the screen that we are using in a moment. Define screen height. All right, so I'll open my browser. Chrome. Then I wanna open it on this side a little bit, and then so I2C screen OLED. Okay, so there are two types. There is this larger one, which is 128 by 64, and then there is this smaller one, which is this is still 0.9 inch, but I want a resolution of that screen. Let's look at this. Resolution of this is 96 by 16. But this is okay. Let's look for another one. Let's look for it in pixel electric. Yep, here it is. So this is the one I'm talking about, 128 by 32. It's half of the other one, 128 by 32. So 128 is the width, the height is 32. Okay, so the width is 128 and the height is 32. All right, So basically we want a simple menu kind of thing. And actually, speaking of menu, I want to let me see whether I can create something like this. Something like this. You can see we have battery. We have a battery indication here. We have some arrows. We have things like, I think this is a time indication. Some letters and characters here, bars, and maybe this I think might be a message thing. Yeah, icons basically. So what I want is to have this as the default setting, and then when someone clicks a simple, just a one button, it goes to a different, shows a menu, one option of a menu, and if you click the same button again, shows another menu. So another menu option. Ideally, you can see this screen is very small, so we want to optimize the space for that. Anyway, so let's start with creating this home screen. Let me call it home screen actually. Yeah, home screen. Right. So because we are creating a state machine, I'm gonna use a basic switch case state machine. Right. So first you have to define what states you are going to be in, and for that we use a type def. Before I do that, let me just write an enumeration. Let's say states, right? So you can have, let's have three states. Let's have the home state being one. Let's have the menu option one, right? And let's have menu option two. Let's have three options, menu option three. Okay, so this is that menu, but now if we want to be using these states, we can define a new type here and call it whatever name we want. But for that we have to use, and for that we have to use a type def enum states and give it a name. Let's say screen states type T, right? Screen state type. See, now when you're creating a state machine, you always have to have a default state, or where does the program start at, right? So to do that, we create a screen variable. Now this is like a data type already, so it's using an int, so int x, int y, but now we can say screen type T, screen states T, initial state. Let me just shorten the code. Init state equals, where does it start at? Should start at home, right? It's just like when you turn on your phone, it starts at a given, the home screen. If you unlock it, it starts at a home screen. So you're gonna say this is a screen states T and home. All right. Let me minimize this. Right about there. Okay. No, that's too small. Okay, cool. That's fine. So it starts here, right? Now, when you press a button, you have to switch to the next state. So we need a button for that. So let's define a button, button pin, right? Button pin. Define menu, let's say menu button. Define menu button. This is going to be, let's say, pin 5. So when you're writing things like hardware, when you're writing these low level hardware firmware, yeah, when you're writing software for the low level, you realize that it has peripherals like UART, I2C button, I2C, GPIOs, etc. So one rule of thumb, or one trick of the trade, is to always start your hardware using functions that follow the Linux systems programming, naming. So what I'm saying is, if you have, for example, a GPIO, right, you want to start, I want to set this pin to input. So I can say pin mode, right? Someone can say pin mode, the button pin, or menu button. This should be menu button pin, menu button pin input, right? Which is totally fine. But to make it more maintainable, you can say, let's define as a static void. You can say GPIO init, right? Then take this function and put it here. All right, then call out function here, init, like that. So if you had this, just by the way, but if you had UART, init UART, you can say static void UART init, right? You can call it init UART anyway, but UART init is the, it's more standard and conventional. All right, enough of that. So we need to initialize this button. Then as a point, we'll have to read that button. So read menu button, all right? So remember, we are repurposing one button. We don't want to have like several buttons. I mean, to make it easier for development, you can have like a button for the next, back, home, etc, like a phone. But if we have one button, we can repurpose it by defining the states that the button is going to be in. So first of all, what I'm thinking is we define the number of presses. So let's say here, button press variables. Okay, so you int 8t, that is, will be able to hold the enough button presses. So btn press is equal to 0. So when someone has not pressed the button, the count of the button press count is 0. So let's read the button somewhere then. So we say static void, let's say button read. So here we want to sample the button. So what you want to do is digital read menu button pin. All right. So this can return a high or a low. So instead of it being void, you can use uint 8t. This code is not optimized because these are 8 bits for just reading one thing. You can optimize it later, but should return this. So let's return this, return digital read. All right. So when you press the button, it goes low. That is what hardware will, that's the hardware we will design. When you press it, it goes low. By default, it's put high. It's at 3.3. So if this guy returns, if this function returns 0, we know the button has been pressed. So let's have another variable here called int 8t. You can use a boolean, but you int 8t btn press. Initially it's high, so let's have it as a 1. So button press, then we read the button. So button read. Okay. So here you can debug if you want to debug ln. Let's say btn press. Okay. Now when you press this button, we should increment the number of presses. Button press, let me call it button press count. Okay, increment it. So let's say if btn press, right? So if it's a 0, what do? We increment this button press count. Okay, then down here we can check for number of presses. So if btn press count is equal to 1, right? Let's start with 0. If it's 0, which means the button has not been pressed. Okay, so this is a button not pressed. If the button is not pressed, we need to set a state, and the state should be home, right? Should be this home. So we need a current state. Let me rename this to current state. Okay, so if press count is equal to 0, current state is equal to what's the name of this? Screen state t home, right? Home. Okay, now if you increment, if you press the button again, else if button press count PRS count is equal to 1, it means the current state is equal to screen state t and option 1. You can use a switch case for these else ifs, by the way. So if btn press count is equal to what? 3, not 2. Current state is equal to screen states. Let me increment the font. Screen states t and option 2, and then let me just copy this, paste and paste. So 2, 3 and 4, option 2, option 3 and option, do I have option 4? I have option 1, 2, 3. I don't have 4. So yep, it's up to 3. Else default state is the home. If it goes that, now else it means that if you press it once, it will count it as 1, twice 2, 3, there will be button press count, it will be 3. If you press the 4th time, I want it to go back to home. So if you press it the 4th time, the 3rd time, the 4th time, it means that it has to reset, so that rather to look back to 0. So we have to set the press count, button press count, what's the name of that? So btn PRS count is equal to 0. But before that, we have to set the state as home first, okay, and then reset. So this is loop back to 0 count, right? Okay, so I'm just gonna write software in this video, and then I will verify it later and tell you how it goes. Okay, so let's see. This is squiggly. Okay, we'll fix that later. So next is, now we need to handle the states based on button presses. All right, so this is now where the FSM comes in. So we use a switch case for that. What are we checking? We're checking the current state. So current state, and then we want to check the we want to check these states right here. So if it's home, we do something. If it's option 1, option 2, option 3, we do something else, right? Now constant expression is the screen states t. If it's home, we have to do something there. What I'll do, I'll copy this part here. First of all, just format it a little bit, paste, 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 and maybe this, push it a little bit like that, like that. Great. So the first one is home, the second one is menu option 1, this is menu option 2, and menu option 3. Okay, so let me minimize this a little bit. Now when we are in home state, we need to display what? Where is that OLED screen? Display this screen here, this data here, right? Now to do that, we can call a function that says show home screen. Let me say screen show home, right? Screen show home. When you're in menu option 1, you can say something else, screen show menu 1. Okay, menu 1, then this guy will be copied to these others to show menu 2 and menu 3. So just quickly paste that here and paste it as a guy here. All right, cool. Now I want to implement these functions now next. So let me just reopen it. Open this file in this editor. Okay, these are the same files, but I want to implement this, so I'll copy that. One thing I forgot is to add function prototypes. Let me just add them here. They are not necessary for this case because apparently hoisting is supported here, but call them PFPs for function prototypes. So this is just to be complete and to follow the convention so that the compiler knows when it's compiling that there is something like this we expect. We expect such a signature of the function. Now the next one is void, static void, screen show home, then static void void screen show menu 1, menu 2, and menu 3. So menu 2, menu 3, menu 2, menu 3. Cool. So let's implement these functions. So it will be show home. Let's implement the show home first of all. So right about here, we need to show the home screen. Now let's write the APIs for the screen itself, right? Because we need to use I2C OLED SSD 1306 0.91 inch screen. For that, we use the Adafruit. We use a library for that. We use the Adafruit I2C library. So I'll just go to my browser. I'll go to my browser. Where is it? Yep, here it is. And I want to search for Adafruit OLED SSD 1306 library. Right, open it in new tab, and You can see here it is. So since we are using platform IO, there's a different way of installing libraries, which is using the platform IO registry. So if you go to the platform IO registry, IO registry, right, we search for this library, Adafruit 1306. Search for this, paste that number there. You can see it right here. Click, go to installation. After you go to installation, we copy this, add the following line to the libdepth option of that. So copy this part, or you can use a command line, but I just paste it here on the PIO. Let me delete this, but libdepth goes paste. Okay, save that. That's okay. So let's look at the examples to see how we use the library. So let's say, for example, this is we are using SSD 1306, 128, 32, I2C. They have the libraries, exactly libraries for that. Okay, so you see they are including GFX and other full graphics. So I don't think it is here. I may just search for it first. Search, how is it? Searching platform IO registry. Browse packages. Where is the search button? Okay. Adafruit GFX. Adafruit GFX. Here it is. So this library is a core graphics library for the display. Drawing things like circles, points, lines, etc. Okay, so as usual, go to installation, copy this line, go back to your platform INI and paste it. Paste it on top of this first one. Again, we go back to our example for SSD 1306. So we have these two libraries, which is okay. We have defined the width and the height. Then we need to reset this. We need to define this these variables here. So what I'll do, I can copy these, but I don't want to copy that. What I'll do, I want to type it. I know there's no difference, but whatever. So I need to exit Zen mode first of all here, because I'm using the browser, and then pull this a little bit to the right, left. Yeah, like that. Now go to main. These defines, I will have them in the defines file. Okay, screen height. Let me define what? OLED reset -1. So this is the reset pin number. You can use it as you can use a different pin, but let's just use what is provided there. We'll optimize the code later. Screen address. Now for address, you can use the I2C scanner to find the address, but they are saying that the default for 128 by 32 is 0x3c. Okay, but we can always check the datasheet for that. So for now, let's just use what is there, 3c. Okay, then this is how we instantiate a class. I'll just copy that line and bring it to the main CPP. So let me create a new section here called screen variables. Paste that line, but before that I have to include the libraries here. So include Adafruit GFX and include Adafruit SSD 1306. All right, so we instantiate the class there, and then we come down here, create this, use the screen width and screen height to create screen height to create the display class object. And then basically these guys are doing an animation of snowflakes. I don't need that. The next thing I need is initialization right here. So I'll have a function that calls a static void that calls the screen API. So init SSD 1306 display init, right? So copy this and call it down here. So initialize, they're saying if it's not found, basically they are waiting forever, but I don't want to wait for long, so I'll copy this part, right? I mean, sometimes you just want to move fast, so you don't want to keep, this code has been written before, so just use it what's there and optimize it for your case, but not always, of course. So I don't want to loop forever here. We can have like retries and mechanisms here. There is a lot of ways you can do that. Retry. So I'll just use this as a to do. Retry I2C scan. Yep. Okay, so switch cap, is this defined? Okay, yeah, it's defined. Okay, cool. Screen address is defined. All right. Next is we initial display buffer contents. The library initializes this with the Adafruit splash screen. If you call display.display and then wait for 2 seconds, I don't want that, but I want to clear the buffer first. Okay, so after initializing, I wanna say display dot clear display, right? I will clear the buffer, and then from there on they start drawing through pixel. Then after every drawing, you call the display dot display. You can say you must call display as a function after drawing commands to make them visible on the screen. That's fine. So there are other API functions like inverting, drawing lines, etc. Okay, so now the next thing I want to do now is create the icons, right? Create icons. So if you remember the image we had, let me just open it here. Copy it here. Yeah, so you can see this. So I want a battery, some arrows, a message, and this bar, network bars. So a battery, so icon. So I use an icon, battery icon. So these screens work with bitmaps. You can't display an image directly like that, but you can use a bitmap. Let me look at this. This looks good, but I want PNG. So go to tools and search for color. Where is the color? Okay, go to images, go to tools, color, transparent, to avoid having pixels on the background. So I'll use this. It's not going to be dynamic like showing percentages, but it's gonna work fine. So let me just save that somewhere here in pictures. No, in the folder itself, the project folder. Just a minute, just a second. let's see, screen FSM. Okay, so I'm gonna create a folder here called assets. Okay, assets. Then we call this. We call this battery icon png. Cool. Then the next thing you want to look for is network icon. Network bars. I don't know what it's called, but network, yeah, something like that. Cool. This is cool. Again, go to images, tools, color, transparent. So let's see. Let me use this one for Wi-Fi. So save images, and this is Wi-Fi underscore icon. Cool. The next thing is this message icon. Let's look for it. So message icon, tools, color, transparent. Let me use this like for the iPhone. Okay, save images, message. Okay, I mean those are enough. So the next thing we do is convert these images to bitmaps so that they can be displayed on the screen. So if we let's look at the library itself. So let me look at the library code. Where is the code? Examples. Okay, I'm back to where I started. Okay, so you see this, for example, this is a logo, is a BMP file, is a bitmap. So there's an array of 8 bytes. I mean, an array of bytes, basically showing what screen should be placed where. And if you look closely, if you are the type of people that can blur their eyes, you'll notice that these ones are arranged like a star. Yeah, they are arranged like a star for Adafruit logo, I think, from what I can see. Right, anyway, that's just that by the way. So we convert this to bitmap using, there's a good tool called image to, I think, image to CPP. Yeah, good, image to CPP. So you choose a file, rather an image. So I'll go to assets. Let's start with the battery, and then we choose a pixel size, which is 128 by 32. We want to read as horizontal. Okay, and background color is transparent. The preview should show us that, I mean, generate code. I mean, the preview should already be showing us, but why is it not showing us? Let's see. Oops. There's a preview. Let's remove this first. Remove. It's not responding. Refresh. Okay, choose files. Go to assets, battery. Yeah, see that. Now, I think is when I reduce the font, not the font, like the pixel size. I put it as 32. Should display it nicely. Or not, doesn't matter. We'll change this later. So from there we want the code output format as Arduino code, and then identifier prefix, we want to say this is battery but BMP underscore generate. cool. So you see it gives us that BMP battery icon. So what you do, you copy this, copy the output, okay, come back to your VS Code. What's wrong with my mouse? Okay, come back to VS Code, and we want to paste that somewhere in our file. So what we'll do, we'll create a new file here called bitmaps.h, then paste. Okay, first of all, obviously we have to create a header for this. It's not recognizing problem because we have not included. You have to include Arduino .h for you to see program. Should be able to see it anyway. So enter guards. So if not defined, what's the name of the file? Bitmaps h define bitmaps h. Okay, so and if where is it? I think I can minimize this. Cool. So this is end if, and if, right? So you can see we have like, we can have an array of several of these. So let's add one more and then go ahead with the rest. So I'll remove this, choose, let me choose the Wi-Fi icon, and there it is. So identifier will be Wi-Fi BMP, generate, copy output. I think it has copied. Let me just copy it. So go back to VS Code and paste that part there. These bitmaps are pretty big, but it's all necessary. Right. So the next thing you check is the naming. You make sure the naming is fine. Wi-Fi BMP, Wi-Fi icon, etc. Alright, so these guys create an array of all bitmaps for convenience. Total bytes used to store images in program is 5024. That's no problem. So one of the biggest problems with actually these bitmaps is the memory. So sometimes if you have a lot of data to display, you need to store these bitmaps in an external flash memory, for example 4 MB flash memory or 8 MB flash memory for that matter. So I'll just keep it at 2, but I'll just have an icon array here, rename this, delete. This should be 2. I have 2 icons, so icons array. I'll paste this battery there, then just delete this. Okay, delete that. Right, so we already have, now we are ready to implement this in our screen, or rather on our screen, and we have initialized the screen. What we need to do is call the screen init here, the setup function, and also fix this. Why is it there's an error here? This debug ln. So to do that, basically debug ln is not an inbuilt function, but I'll define the serial. I'll route serial to debug. Okay. So what I'm saying is, if I have serial debug, I can say using macros define debug ln, debug first of all as serial dot print. Okay, so it won't recognize serial. I have to include Arduino. Okay, so debug X, right? So you print X, then you define debug ln X. This is serial dot debug dot print ln, right, X. So you can have others like define debug F, X and the format Y. This you can have a serial dot printf X Y, like that. So you should be able to resolve that error. Okay, cool. So debug ln button press, cool. Okay, it's gone. All right, so to keep this video short, I will end it there, and next time we'll we'll finish with the bitmaps and see how we can call them from this file and display them on the screen. The hardware is set up, and yeah, so we have that. Next will be just now to add a function callbacks or handlers for each of these states. So I hope you learned something from this one. Next time we are going to finish this piece of code and see how it goes. It's actually not going anywhere, just a random practice run to master the basics of such basic things. Right, all the best and have a good one.